Alright, here with another set of videos. This one's over the applications of logarithms. The first application that we're going to look at is carbon dating, and it has to do with, of course, finding out how old really old objects like fossils are. And so what that has to do with is how fast the isotope of carbon, namely carbon-14, degrades radioactively. So we know that it has a half-life of 5,700 years. And we see that number here in this constant that's part of this equation. So there is an equation that you're going to have, this carbon dating formula, where it says A sub t equals A naught, which is the original amount, times e to the negative kt. And again, k is this constant here, the natural log of 2 divided by 5,700. So this is always constant as long as we're talking about this particular radioactive element. So again, what these numbers mean, the amount at the time we're looking at after a certain amount of years is equal to the original amount of carbon-14 times e to the negative kt. And so basically, it's going to be a lot of just kind of plugging into the formula and then solving for t, since these are questions about how old something is. We want to figure out the time. And so what the first thing they tell us is if a fossil contains 1/5 of the carbon-14 contained in a living sample, estimate its age. So what we know is that A sub t, so this fossil, however old it is, has 1/5 of the original amount of carbon-14 that it's supposed to. So it has 1/5 A naught. What we have here is a way of substituting out A sub t in this formula. So I'm going to take this, and it's going to go right there. So I'm going to rewrite it as 1/5 A naught equals A naught times e to the negative kt. Well, if you notice, there's an A naught on both sides of the equal sign, so those will just cancel. This is something that's going to happen every time we do a problem like this, that those A naughts will cancel. So kind of the idea we're going to take a hold of is that we can just skip this step and get right to this simpler formula of however much is left equals e to the negative kt. So we can take this 1/5 that we started with and then just rewrite the problem like that. So here's our actual equation that we're going to solve. So you notice we have an exponential equation. Of course, we're going to turn that into a logarithmic equation. And since it's base e, it's going to be natural log. So that's going to be the natural log of 1/5. I'm going to put that in parentheses since it's a fraction, equals negative kt. And we are trying to solve for t, so I would just divide by negative k. So that means t equals the natural log of 1/5 divided by negative k. Remember, k is a number, we just don't have a value for it right now because it's this expression. But now we can take this and plug it into our calculator. So the first thing we do is show you how to store a variable in your calculator. And so what we're going to do is take the natural log of 2, and then we're going to divide that by 5,700. And so you see here why we don't want to write this number down, we just want to give it a letter. So that's why we call it k. And what we're going to do is we're going to store that. So here you have this storage button on your calculator, STO. And then you hit any letter you want, so alpha, and then I'm going to pick k since we're talking about k. So my answer is now stored under k. So if I clear that out and I just hit alpha k, it'll bring that value back up for me. And you can do that with any of these letters here. You can store a value in there. And so we wanted the natural log of 1/5 divided by negative k. So I'm going to hit natural log 1/5 divided by negative, and then alpha k. So there it is. So this is 13,234 13,235 if we round a little bit, years, since we're talking about how old this sample is. I'm going to approximate this. This is just an approximation. It's never exactly this old. So I'll say to the nearest 100 years will be pretty good. So 13,200 years will be a pretty good example or approximation. All right, let's see that again. So I have another example down here. So here we have another fossil that contains 42% of its carbon-14 compared to a living sample. I want to estimate its age. So if we take advantage of what we saw on the first example where the amount remaining just gets set equal to e to the negative kt, we can go right to that. So 42% of course is 0.42. So I'm just going to write that as an equation. 0.42 equals e to the negative kt. And then just like last time, we want to turn this into a logarithmic equation. So rewrite that as the natural log of 0.42 equals negative kt. So then dividing both sides by negative k, we get the natural log of 0.42 divided by negative k. So we pull up the calculator. Natural log 0.42. Now k is still the variable that I assigned it for earlier, so that's not gonna. That's nice. That's one of the things that's nice about that storage function. It holds onto that stuff until you reset your calculator or until you reassign that variable a different number or value. So here we get 7,134 years. So let's call that 7,100 years old. I don't know there's a particular rounding value to use, but I think to the nearest 100 years is pretty good. So actually pretty easy equations to solve.